Okay, so here we go again, yet another set of questions for you to consider and practice. Just run through the questions first, so you can stop the video at any time and try the question, and then obviously scroll through until you see the answers and check yourself. Okay, so here we've got a question on the sine curve. Then we're going to do a couple of bits on the rules of indices, the laws of indices, and a little bit on the volumes of prisms and reverse calculations, and then estimated mean, just to check you remember the formula and how to use it, and to finish off with something to do with compound interest. Okay, so I'll get started. Okay, so we can see here that we've been given a sine curve, and they've told us the domain is from negative 360 through to 360. And the things we've got to remember about the sine curve is that the period of the curve is 360 degrees, which means it repeats every 360 degrees. The amplitude is equal to plus or minus 1. And we've got to remember that the peak of a normal sine curve is 1, and the trough, the minimum, is negative 1. And we need to remember these special values, that when it peaks it was above 90 degrees, and when it goes through 0, 180, and then when it gets to the minimum it's 270, and then it goes to 360, and it just repeats every 90 degrees. So this will be negative 90 degrees, negative 180 degrees, negative 270 degrees, and negative 360 degrees. So those are the key points of the sine curve, and now we can just read off the coordinates. So it wanted the coordinates of P, and say the coordinate of P is going to be 180, 0. Got to remember that it wants a coordinate, so it needs both numbers, the x coordinate and the y coordinate. And the coordinates of Q, well, we've got negative 270 and 1. So negative 270 and 1. Okay, so a little bit on the sine curve. Remember, they could expect you to remember how to work with the cosine curve, which again goes from 1 to negative 1. Starts at 0 there, and then 90, 180, 270, and again its period is every 360 it repeats and goes through 1 and negative 1. And they could also expect you to remember the tan curve, and we've just got to remember the two key things with the tan curve is it has an asymptote every 180 degrees, and if you remember this particular part of it, then we remember then the next one will be 270, and it basically just keeps repeating through there. So the 0 point was at 0 there, and the period's 180 for the tan curve. So that's the tan of x, or the tan of theta, and that's the cosine of x, or the cosine of theta. So those are the three curves for the trigonometric functions that you need to remember, guys, and to be able to work with them. Okay, so this next question talks about a triangular prism. It said the word prism, so it talks about volume, so we should be thinking straight away that this is about the cross-section area times the length between the two congruent faces, and the congruent faces are here, and if we imagine what's happening here, then this triangle here is exactly the same as the triangle at the back there, and it's got parallel edges between the two end faces, so therefore it's a prism. And it's asking us to work out the height of h. So literally we just bung in our numbers. So v is equal to a half base height for the area of the triangle, because that's the cross section, times the length, and we know that we've got 24 for the volume, and we know the base length is 6. We don't know the height yet, but we do know the length is 5. So If we halve 6, we get 3. 3 5s are 15, so we have 24 is equal to 15 times h. Half of 6 is 3, 3 5s are 15, so that. And then h will be 24 divided by 15, and we know that that cancels by 3, or as a factor of 3 in denominator and numerator. So we end up with 8/5, which gives us an answer of 1.6, or 1 3/5. So the height of this is 1.6. And we should do a quick check to make sure that it works. So if we do half of 6 is 3, 3 times 1.6 is 4.8, and 4.8 times 5 is 24. So that seems to work. Okay, that's how that question could be done. This question talks about working out the value of 81 to the power of negative a quarter. So it's going to be using the laws of indices. This particular law is about the negative power of the fraction, which is equivalent to the nth root because of the denominator, the denominator of n. So it's the nth root of a to the power of m. And the negative power says that it's the reciprocal, so it's 1 over that. So if we put in our numbers appropriately, then we should be able to get this to work. So we've got 1 over, and the nth root will be the 4th root, so we want the 4th root of 81, and we're doing it to the power of 1. The 4th root of 81 is 3, so this becomes 1 over 3 to the power of 1, which finishes off as 1 over 3. Because anything to the power of 1 is the number itself, or the letter of its power of 1, and so on. So that's how that one could be done. And the question goes on and talks about write this as a power of 2 in terms of x. Okay, so it wants as a power 2, so there's your hint. Change everything to powers of 2. So if you remember our 2 power series, then 16 is the same as 2 to the power of 4, and 8 is the same as 2 to the power of 3. And that's been raised to the power of 2x. We then know that a power raised to a power, you multiply the 2 powers, so that becomes 2 to the power of 6x. 2 to the power of 4 is still there, timesing. And then when we times with the same bases, then we can add the powers. So we end up with 2 to the power of 4 plus 6x. And that's that question, by just thinking through the wording and remembering our laws of indices. Okay, so practice those, guys, because they will be there in your exam somewhere. Okay, so this question talks about doing the estimated mean, and it's, as soon as we see the words estimated mean, then we should be thinking of the formula. So the estimated mean is equal to the sum of the midpoint times the frequencies divided by the sum of the frequencies. So I need to remember that means total or sum of. And this is just the symbol we can use for the mean. So they've been nice on this question because they've given you the 2 columns already drawn. Quite often they don't. So here is where we're going to calculate the midpoint of each interval, and then we're going to do the midpoint times the frequency. So we can see the midpoints of this interval. We have the 2 ends, 0 and 5, halve it, 2.5. 5 and 10, 15, halve it, 7.5, 10 and 15, 25, halve it, 12.5, 15 and 20, 35, halve it, 17.5. And here then we're going to end up doing the midpoint times the frequency. So the midpoint times the frequency. And this was a calculator paper, so I'm not going to waste any time. So we've got 7.5 times 48. And then we've got 12.5 times 30. And then we've got 17.5 times 22. And basically, they've already told you what the sum of the frequencies is. It's 120. Because I've added the frequency column for you, and now we just need to add up these. So we've got 50 plus 360 plus 375 plus 385, so 1170, and then we need to be doing 1170 divided by 20, so divide by 20 equals, so 58.5, and it's about a distance, and it's in miles, so this is 58.5 miles. Always useful to put the units down for these kind of questions, because it might be a compare type question, and then you can compare in context, which always is going to give you more marks if it's a high scoring question. Okay, so estimated mean, remember the formula, remember the add-on columns. It's estimated, remember, because we don't know exactly what these 20 students walked. All we know is they walked between 0 and 5 miles. So it's an estimate that we use the midpoint. Some will be above and some will be below. Okay, so that's estimated mean. Alright, so this question talks about investing £6,000 at a compound interest rate. He wants to earn more than... Right, okay, so we have a formula for all the compound time effects, growth and decay rates, exponential rates. This is an exponential rate because it basically means that you're compounding it every year, so you get 1.5% on what you had before, then you get that extra, then you get 1.5% on that extra, and so forth. So it's a compound. So if the graph of this was drawn, then it would be a curve going up and up and up. So this tells us then that the x value is, because it's a compound interest rate of, it's an increase, so that's going to be 1.015 as a multiplier. That's our x value. Sorry, not our x value, that's my fault. It's q, it's the multiplier. Do apologise. Okay, so q is the multiplier, x is the number of time periods, p is your initial value, and y is your new value. Okay, so that's got the letters defined properly. So our initial value was 6,000, so he wants to earn more than £1,000 interest. So if he wants to earn more than £1,000 interest, then we're looking for when PQ to the power of x is greater than 7,000. Because if he gets £1,000 interest, then he must have £7,000 in his account. So that's what we're trying to solve. We know the initial value was 6,000. We know the multiplier was 1.015. The only thing we don't know is the number of years, because x is being defined by years, and we want that to be greater than 7,000. So 1.015 to the power of x has got to be greater than 7,000 over 6,000. So 1.015x has got to be greater than... Okay, this is a calculator question, so 7,000 divided by 6,000 equals, so 1.16 recurrent. Alright, so basically it's a trial and error until we get this to be true. So I'm going to try 5 as a good starting point, because these questions tend to be somewhere between 3 and 10. On GCSE papers, so we'll try that. So 1.015 to the power of 5. So that's so good. So I'll try 10. 1.015 to the power of 10. That's getting closer. So 1.015 to the power of 11. Okay, so we can see that power 10, so when x was 10, 1.015 to the power of x gave us an answer of 1.160, and then when 1.015 to the power of 11 gave us an answer of 1.177, which is greater than this. So the answer was the least time in whole years, so it'll have to be 11 years. So the answer, because I wanted the least time, then the answer is going to be 11 years. Okay, so that's how that question could have been done. Alright then guys, good luck in your revision, keep going.